Here's the typical setup for performing static radiography. Up at the top, that's where our X-ray tube is. On the table, I have a flat panel detector, and then on that I have a phantom elbow. The phantom, it's got real bones in it, and we can't X-ray each other, so we use those. You can see the round end on this in that cylinder. That's where the X-ray tube is actually housed. That's lead lined, it's filled with dielectric oil, and the tube is sitting in there. You can see the light field on the flat panel detector. That is showing us where the X radiation is going to expose. So we produce the X radiation up here. It comes down, as if we could see it, it would look like a spotlight, and then it goes through the part. The part's going to absorb some of the X-ray, it's going to scatter some of it, and then we capture the image on the other side. We do not get an image back like you do with ultrasound. We shoot clear through the part and capture it on the other side. This is our control panel. It's a touch screen monitor, and this is where we set the energies for our X-ray beam and the intensity of our beam. I'll go ahead and make an exposure, and we'll see, and then there's our raw data image. This is being processed in the background, and there you have the actual image right there. So we shoot the X-ray photons through the part, capture it on the flat panel detector, and then display it on the monitor. This is an actual X-ray tube. You can see the scale of it. What you have, this is a Pyrex glass envelope here, and on the inside, you can see at this end here, we have the cathode. This is the negative end, and then we have the anode. And the anode is where our target is, where we produce the X radiation. This sits in the tube housing just like this, and then the anode will spin to dissipate heat, and the cathode remains stationary in the tube. An X-ray tube, if you burn one out, you're looking at anywhere from $10,000 to $50,000 to replace it. Here's another X-ray tube. It's just a little smaller than the one that we did previously. And I wanted to show you this one so I can show you how they actually spin the anode. Remember, I told you the cathode remains stationary. The anode has the rotor here, and this will spin. The way that we do that is we take and we turn this into an electric motor by putting the stator over the rotor. And now we have an induction motor. That's how we spin the anode. Now the whole purpose of spinning that anode is for heat dissipation. Here you can see an anode. This is the face of it. It was sitting in that tube just like this, and it's going to spin like so. Now those bearings, they're shot. The bearings are bad, and that's why it's so noisy. What happens is that cathode is going to be sitting right here, and you can see the track around here. That's called the focal track, and that's where we're going to bombard this with the electrons. We have the negative half of the tube. This is the cathode, and I'll take and show it to you. Filaments. There are two different filaments in there, small focal spot and large focal spot. We only use one at a time. You see the little springy guys in there? Yeah. So what happens is we have the little spring, we put current through it, the twists create resistance to the current, and so these heat up to over 2200 degrees Celsius, and when we hit that high temperature, we will have thermionic emission. In other words, we're going to boil electrons off of those filaments. So this is going to be our source of electrons here for X-ray production. We're going to put a negative charge on the cathode in the focusing cup, and simultaneously we're going to put a positive charge onto the anode itself. The volts, in other words, we use energies anywhere from 60 to 120 kVp, that's kilovoltage peak, and so that would be, if it was 100 kVp, then our highest energy photon would be 100,000 volts. So we have a positive charge here, and it's going to accelerate those electrons across the tube. And then we slam them into this target here, down here, and that is going to be the sudden stoppage. So we have a source of electrons. Number two, we have a way to accelerate the electrons. Number three, we're going to have a way to stop those electrons for X-ray production.